Hi, so I wanted to show you how to transform this equation here from your base graph. So you have a base graph of, we can use y equals 2 to the x, the graph we know and love. And we're trying to get to this new one. And it can be confusing on what your a is here and what your b is. So I just wanted to go over that. So back to chapter 2, if you write out our transformations, we had something that looked like this. Oops. B. And then plus d. Okay. And so in this, the a value is right out front. It's before the function happens. So in this case, if we had an a value, it might look something like this, okay, compared to our base graph of y equals 2 to the x. So in this case, then we would be multiplying, all of our y values are now getting multiplied by 5. So that would be an a value. If that was negative, then it would look something like maybe you would get y equals negative 2 to the x, or maybe in this case, we could have negative 5 times 2 to the x. So it's going to be out front of your function. So that's our a value. And so what a is doing is it's affecting our y, it's affecting our output values. And so if this, okay, if a is negative, then it's affecting our y values. So it's reflecting y values, reflect y values over the x-axis. The b value is what is attached to the x. So in our case then, we could say the b value, or I'm just going to do a different example actually, because ours is kind of complex. But let's say you had something like this, y equals 2 to the negative x. Then that negative sign is attached to the x, and so that's our b value. So it's affecting our x value. If we had a positive 5 for x, now, if we had a negative x, we're going to have a negative 5. So it's taking our x values and manipulating them in some way. So if it's negative, it's reflecting our x values across the y-axis. And if it's a number like 2 or 5 or 1/2, then we're talking about horizontal stretches and shrinks. But if it's negative, reflect x values over the y-axis. The c value is also kind of attached to the x. It's affecting the x. And so if your c value, I always think of it as doing opposite what I think. So if you have like x minus some number, then that's moving your graph to the right. And if you have x plus some number, it's moving your graph to the left. So this is shifting left or right. And then the d value is on the end. And so in our case then, like we do our function, and then at the very end, after we've kind of done that function, if you will, then we're left with our 2. We're adding 2. We're tacking on 2 more to each of our y values. So therefore, the d is affecting our y values, and it's going to end up shifting the graph up or down. So let's move back to our example. So we've got this, actually, we were given it like this. So let's start there. So the first thing I would do is I would switch it back to what I had just written above. So I always like to think of my x values first. So I would just switch the order of those two to negative x plus 1. And then the next thing I do, I like to graph these in order A, B, C, D, because if you do it in that order, it will always work. And so what I would do is I would actually factor out the negative sign so that I have something that looks like this. Okay, so whatever my coefficient is in front of the x, I would factor it out in this way. Now, once you're here, we can do our transformations. So we start with a, but there's nothing in front of that 2, so we don't have an a value. Our b, so b is kind of attached to the x. In this case, then, it's negative. So b is -1. And so that means we're going to reflect our x values. And I'll put a 1 here because we should do this in order. So reflect our x values over y-axis. The next thing we want to deal with is our c value, so the thing attached to our x. So in this case, we've got x -1. So the minus means we're shifting to the right. So here we're going to shift right by 1. And then the last thing we're going to do is that +2, our d value, which is going to shift the whole graph up 2. So if you need to graph this thing, what I would do is you can put out your kind of standard points, and you can write this on your formula sheet, but your standard xy coordinates for y equals 2 to the x. So we've got, and this is in your notes too on page 5 of chapter 5, so we've got a point at 3, 8, and then 2, 4, 1, 2, 0, 1, -1.5, -2.25, and -3.125. Okay, so step 1, I'm reflecting my x values. In other words, I'm multiplying my x values by -1. And so that gives me, so each of my x's, I multiply by -1. Okay, my next step is to shift all my x values right by 1. So we're going to be adding 1 to our x values. So I'm going to do that. And so add 1 to every x value. And then our third step is we're shifting the graph up by 2. In other words, we're moving our y values up by 2. So I'm going to do that here. So here we shifted right 1, so we did +1. Here we're shifting up 2, so we're going to do +2 to our y values. And so this will be our new set of ordered pairs to graph that transformed graph. And if we wanted to check our work, I've put this graph in Desmos. So let me show you that. Okay, and so here is Desmos, and I've input that graph over here. Let me zoom out a bit. And let's just check if our points make sense. So we're saying there's a point at -2 and 10. Yep, there it is. -1 and 6. 0 and 4. 1 and 3. 2.5, or sorry, 2 and 2.5. It's right there. 3 and 2.25. and 4 and 2 1/8. So we were correct in this. Now, there is another way to do this too. And so if you're interested, stay on and I'll show you that way as well. So the way your textbook does this one is, so let me copy it down again. So we had y equals 2 to the 1 minus x plus 2. So instead of doing A, B, C, D, what they do, I'm just going to write the x first again, is they first do their translations. So they do, that's a +1, so we're going to shift left by 1. And then we've got a +2, so we're going to shift up 2. And then the last thing they do is deal with the reflection. So they reflect x values over the y-axis. So if you want to do this method, just make sure you're doing it in this order, 1, 2, 3. If we follow those 3 steps, we should end up back at the same place we ended up with our answer up above. So I'm going to write out those points again and just convince myself and you that we get the same answer. Okay, so the first thing we're doing is shifting left 2. So that's going to change all of these values. So they're going to, all of our x values then, we're going to subtract 2 from. And then all of our y values here, we're shifting up 2, so we're adding 2 to each of our y values. And I'm just going to leave those as mixed numbers because it's easier to graph that way anyway. Okay, so we did that. Last step here. So now we need to reflect our x values over the y-axis, which means we're multiplying our x values by -1. So let's use blue again. So all of our x values then we're multiplying by -1. Uh-oh, we're not going to end up at the same place, are we? Oh, because I can't add shift left by 1. Oh, and then look, I did not do that, did I? Okay. So here, this should be a -1. We're shifting left by 1. So I got all those values wrong. So they go down 1. Okay, now we can multiply. We're doing step 3 where we reflect our x values. So we're multiplying all of our x values by -1. And that will bring us, we do nothing to our y values. So that gives us the same points that we had. Whoops, what am I doing? Do nothing to your y values. Do nothing, leave them alone. So we end up with the same values though that we had using my method up above. So you can use whichever one you like. The reason I like mine is I like to just do them in order all the time, A, B, C, D, but it does involve factoring out your coefficient in front of your x. Okay, I hope this helps.